creating a constructor for config. So far, we've extracted the logic responsibility for parsing the command line arguments from main and placed it in the parseConfig function. Doing so helped us see that the query and file name values were related and that relationships should be conveyed in our code. We then added a config struct to name the related purpose of query and file name, and to be able to return the values names as struct field names from the parseConfig function. Moving on. So now the purpose of the parseConfig function is to create a config instance. We can change parseConfig from a plain function to a function named new that is associated with the config struct. Making this change will make the code more idiomatic. We can create instances of types in the standard library, such as strings, by calling string new. Similarly, by changing parseConfig into a new function associated with config, we'll be able to create instances of config by calling config new. Listing 2.7 shows the changes we need to make. Okay, so they're just telling us we can make our code more idiomatic by adding associated functions to the struct config, which makes sense. Is it really needed for this example? It's pretty much overkill, but this is just an example. We're supposed to kill it, overly kill it. And here is the change. We have our implementation blocks for config, where we make the function. We have our function new, which is going to be the associated function, which is going to take the args, string, return a config, and it's the same stuff, same exact thing as parse. Let me just cut it, paste. Get rid of this. This is no longer here. And this is now config new. That was the only thing changed. I have an error. Was there anything else changed? Expected args. This is a pointer. Everything still works as expected. These are very small incremental refactoring changes. Alright, moving onward. We've updated main where we are calling parse_config to instead call config new. We've changed the name of parseConfig to new and moved it within the implementation block, which associates the new function with the config. Try compiling this code again to make sure it works. Been there, done that, moving onward. Fixing the error handling. Now we'll work on fixing our error handling. Recall that attempting to access the values in the args vector in index 1 or index 2 will cause the program to panic if the vector contains fewer than 3 items. Try running the program without any arguments. It will look like this. We've done that too. Moving onward. Well, we can look at their example. Cargo run. They have nothing here, and we panic because index 1 is out of bounds, and we have a backtrace. The line index out of bounds, the length is 1, but the index is 1, is an error message intended for programmers. It won't help our end users understand what's happened and what they should do instead. Let's fix that now. Improving the error message. In listing 12-8, we add a check in the new function that will verify that the slice is long enough before accessing index 1 and 2. If the slice isn't long enough, the program panics and displays a better error message than the index out of bounds message. This is great. This is what we need. This is easy to add in the new function. So this is just an example of us taking logic out of main. Well, this logic was never in main. It should have been, but it wasn't. And adding it someplace else that is easy to test and easy to verify. So in the new function, associated function to config. We do a check to see if the args is long enough. Args, something changed there, dot length. And if it is less than 3, we start the panic. Not enough arguments. And to verify that we see that, we can try running a program again. Let's do it with just the. And here's the panic message, not enough arguments. Not the greatest message, but it's something. It's better than what it was. This code is similar to the guess new function we wrote in listing 9-10, where we called panic when the value argument was out of range of valid values. Instead of checking for a range of values here, we're checking that the length of args is at least 3, and the rest of the function can operate under the assumption that this condition has been met. If args has fewer than 3 items, this condition will be true, and we'll call the panic macro to end the program immediately. With these few lines of code in new, let's run the program without any arguments again to see what the error looks like. We ran it with 1 argument. This should be the same thing. And panicked at not enough arguments. This output is better. We now have a reasonable error message. However, we also have extraneous information we don't want to give our users. Perhaps using the technique we used in listing 9-10 isn't the best to use here. A call to a panic is more appropriate for a programming problem than a usage problem, as discussed in Chapter 9. Instead, we can use another technique you learned about in Chapter 9, returning a result that indicates either success or an error. Okay, so in this paragraph, what they're saying here is that, yes, this message is better. However, all this other stuff, this junk, we don't want our end users to see all of this, but this is associated with a panic. But if we don't want to see this and we still want the message, we have to do something else. And they're saying we can do something else by using a result instead of a panic. Returning a result from new instead of calling panic. We can instead return a result value that will contain a config instance in the success case and will describe the problem in the error case. When config new is communicating to main, we can use the result type to signal that there was a problem. Then we can change main to convert the error variant to a more practical error for our users without the surrounding text about thread main and Rust backtrace that a call to panic causes. Listing 12-9 shows the changes we need to make to the return value of config new and the body of the function needed to return a result. Note, this won't compile until we update main as well, which we'll do in the next listing. Alright, so we have config, we have our new, we're returning result, which is config, and a static string. And okay, and this is a lifetime static string, so this string is going to exist for the lifetime of the program. I guess this is okay because if there's an error with the config, we should be ending the program immediately, so lifetime forever should be fine. So let's make that change now. So we want to make you a result. Config, and then we have our lifetime, which is going to be static, and we're making that to a string. And then down here we're returning, this is going to be an OK, small k, if everything's good. And this, instead of being a panic, this is going to be our error. Return error. However, this code is not going to compile yet because we haven't dealt with the result here. Our new function now returns a result with a config instance in the success case and a static string in the error case. Recall from the static lifetime section in chapter 10 that the ampersand apostrophe static string is a type of string literal, which is our error message type for now. We've made two changes in the body of the new function. Instead of calling panic when the user doesn't pass enough arguments, we now return an error value, and we've wrapped the config return value in an OK. These changes make the function conform to its new type signature. Returning an error value from config new allows the main function to handle the result value returned from new function and exit the process more cleanly in an error case. I see. So the main reason why we did all of this, well, not the process to going through it, that was just like the thought process of how you refactor step by step by step. But the reason why we added a result here is because main should be handling the errors, and that was one of the bullet points that they pointed out, I think a page ago, is that main handles errors. In order for main to handle errors, we have to bubble them up. In order to bubble them up, we have to use a result. Calling config new and handling errors. To handle the error case and print a user-friendly message, we need to update main to handle the result being returned by config new. As shown in listing 12-10, we'll also take the responsibility of exiting the command line tool with a non-zero error code from panic and implement it by hand. A non-zero exit status is a convention to signal to the process that called that program that the program exited with an error state. So this paragraph, so right here we're just talking about we're going to handle the error, we're going to do it properly, but also we're going to follow convention of command line applications, which is if there's an error, we're going to exit with a status that is not zero. Zero means everything is cool and dandy, whereas if it's not zero, let's say it's 1, 2, or 3, then we have an error that occurred while running the program. Explicitly, these numbers mean something, like there's different types of errors and a convention completely around that. However, that's I don't know that off the top of my head. I know of it, I just don't know I don't know all the details. So moving on, to do this explicitly for us, we have to import the process. So from standard library, use process. Use std process. And we're going to be using this to have an exit code that is non-zero, which they have right here. So in the main function, we have our config, right? New. And we do unwrap or else. We're passing in the error, so this is the else case. And with this error, we're going to print the problem for the user. So print line problem parsing arguments, the error, and then after that process exit 1, and this is the number that we exited with, which is non-zero, which means it was an error. And now we should be able to run this seemingly, given that I wrote everything correctly. And bam, now this is the only thing that prints out to the user. Problem parsing arguments, not enough arguments. That is very reasonable, and we no longer have all of the panic stuff. In this listing, we've used a method we haven't covered before, unwrap or else, which is defined on result TE by the standard library. Using unwrap or else allows us to define some custom non-panic error handling. If the result is an OK value, this method's behavior is similar to unwrap. It returns the inner value OK is wrapping. However, if the value is an error value, this method calls the code in the closure, which is an anonymous function we've defined and passed as an argument to unwrap or else. We'll cover closures in more detail in chapter 13. For now, you just need to know that unwrap or else will pass the inner value of the error, which in this case is the static string, not enough arguments, that we added in listing 12-9 to our closure in the argument error that appears between the vertical pipes. The code in the closure can then use the error value when it runs. So what they're saying here is that unwrap works just like unwrap does. If your result is OK, it passes the whatever was inside OK. The or else part is the part that we really care about now for error handling. The or else part, at least in our situation, we have a static string that is in our else, and that is going to be our error. And we put it here as an error. That error message, which we written out explicitly, not enough arguments, gets passed within this closure into this thing, and then is used right here for the user-facing message, which is the error. Outside of that, we just exit out of the process. Cut the program, make sure it doesn't run any longer. We've added a new use line to bring process from the standard library into scope. The code in the closure that will be run in the error case is only 2 lines. We print the error value and then call process exit. The process exit function will stop the program immediately and return the number that was passed as an exit status code. This is similar to the panic-based handling we used in 12-8, but we no longer get all that extra output. Let's try it. We did. It's here. It's the same as this. Great. This output is much friendlier for our users. Agreed. Extracting logic from main. Now that we've finished refactoring the configuration parsing, let's turn to the program's logic. As we stated in separation of concerns for binary projects, we'll extract a function named run that will hold all the logic currently in main function that isn't involved with setting up configuration or handling errors. When we're done, the main will be concise and easy to verify by inspection, and we'll be able to write tests for all the other logic. Listing 12-11 shows the extracted run function. For now, we're just making the small incremental improvement of extracting this function. We're still defining the function in source.main.rs. The reason why they added this line here is eventually we're going to move it out to libs. But let's take a step back. So here they're saying that we're going to do separation concerns for binary projects. We're going to move all of the logic out of main and put it someplace else. We're doing this one step at a time. Eventually this logic will live in libs.rs, but for now, since we're doing it incrementally, we're going to create the run function and leave it in main. And here's what the run function looks like. Run, it takes in a config, and then it reads the file. Because right now, this is the body of main. This is where the logic is happening. Everything up here was just configuration. So let's create a run function. I'll put it above main. Why not? Function run. Config, takes in a config. Put a space there. And it just takes this information. Cut. Paste. And now we can call it run and pass it in config. And everything works the same. Let me get a good case actually. Poems.text. There we go. Poems.text. Here's the poem. The run function now contains all of the remaining logic from main, starting from reading the file. The run function takes the config instance as an argument. And yeah, we can go over it again. So run takes the config instance, which is configuration, and then all the logic happens from the configuration. And that is currently just reading of the file. Returning errors from the run function. With the remaining program logic separated into the run function, we can improve the error handling as we did with config new in listing 12-9. Instead of allowing the program to panic by calling expect, the run function will return result TE when something goes wrong. This will let us further consolidate into main the logic around handling errors in a user-friendly way. And listing 12-12 shows the changes we need to make to the signature and body of run. Alright, cool. So what they're saying here is that all of the new logic is going to be placed in the run function, right? However, the run function does not handle errors. The run function is going to be moved to lib.rs. Error handling should be happening in the main function. And that's just so that we can have all of the user-friendly errors all in one place and we don't have to go looking for them. It makes sense. But because we want to do that, run needs to return something when there's an error, and it's going to return a result. So we're adding another import. Use standard library error. Okay. And in the run function, find it right here. That's the syntax. We take off this expect, right? We add a question mark. Question mark means, if I recall correctly, if it's okay, it returns the thing inside okay to content. If it's not okay, it raises the error. And the error is what we want to do right now. And at the bottom of this, if it reaches the end, we just want to return an okay. And the okay is going to be empty. And here we need our return type. It's going to be result. Okay is going to be empty. But for the errors, they're using something we haven't really messed with or seen before, which is a box. Dine error. Run config. Technically speaking, we should probably do something with this too, because this is going to bubble up and we need to be able to read the errors and print them out properly. But let's see what they say. Look at this change. We've made 3 significant changes here. First, we changed the return type of the run function to result, empty, box, dine, error. This function previously returned the unit type, empty. And we keep that as the value return in the OK case. For the error type, we use a trait object, box, dine, error. And we brought standard error into scope with a use statement at the top. We'll cover trait objects in chapter 17. For now, just know that the box dine error means that the function will return a type that implements the error trait. But we don't have to specify what particular type the return value will be. This gives us flexibility to return error values that may be of different types in different error cases. The dine keyword is short for dynamic. Okay, that makes sense. So this dine thing and this box thing, they don't explain the box. They explain dine, which is short for dynamic, and they explain why we used error, which is the trait. That's what we imported. So this means that we can return anything that has or that satisfies the error trait, which allows us to return errors of different types, which is cool and needed because run is going to hold all of the logic of what our program does. Yes, we might have to outsource things to different functions along the way, but they're probably going to bubble up to run, and run's probably going to bubble that error up to the main function. And because that can be many different types of errors, this is what we need, something that can dynamically take any error. Understood? Second, we remove the call to expect in favor of the question mark operator. As we talked about in chapter 9, rather than panic on an error, question mark will return the error value from the current function for the caller to handle. Third, the run function now returns an OK value in the success case. We've declared the run function success type as the empty brackets in the signature, which means we need to wrap the unit type value in the OK value. This OK of emptiness syntax might look a bit strange at first, but using the just quotations empty tuple like this is an idiomatic way of indicating that we're calling run for its side effect only. It doesn't return a value we need. Alright, yeah, so what they're saying here is that though this looks weird, this is idiomatic. The reason why this is idiomatic is because it's clear to somebody who's reading this code, we don't need the stuff that's in OK. We just wanted to get to this part. What we really care about in this situation is the type of errors that are returned. If we get to OK, we know everything runs successfully. Meh, good. Moving onward. When you run this code, it will compile, but will display a warning. And I actually haven't ran it yet, so I haven't seen this warning. By all means, yep, there is the warning. Because we're not handling the result. Yeah, this is why I didn't run it earlier. So the warning says, unused, must use, on by default. This result may be an error variant which should be handled. We are not handling the result. Rust tells us that our code ignored the result value, and the result value might indicate that an error occurred. But we're not checking to see whether or not there was an error. And the compiler reminds us that we probably meant to have some error handling code here. Let's rectify that problem now. Handling errors returned from run in main. We'll check for errors and handle them using a technique similar to the one we use with config new in listing 12-10, but with a slight difference. Alright, now I'm curious because I'm not familiar with box and dine, and I kind of want to see how these errors are done. So they did an if let error e print line application error. And there's the e and exit process 1. Okay, they did an if let, and if it's an error, then we do this. I see. That makes sense. So let's write that down here. If let, if it's of type error, then do the following. Print line application error, and we print out the error, and then we need to exit the process again. Process exit 1. Run this again, and 0 warnings. Cool. We use the if let rather than unwrap or else to check whether run returns an error value, and call process exit 1 if it does. The run function doesn't return a value that we want to unwrap, in the same way that config new returns the config instance. Because run returns just emptiness in a success case, we only care about detecting an error, so we don't need unwrap or else to return the unwrapped value because it would only return emptiness. The bodies of the if let and the unwrap or else functions are the same in both cases. We print an error and exit. So the next part, splitting code into a library crate. You've been waiting for this. Our mini-grep project is looking good so far. We'll split the source/main.rs file and put some code into the source libs.rs file so we can test it and have source/main.rs file with fewer responsibilities. Let's move all of the code that isn't the main function from source/main.rs to source/lib.rs. The run function definition, the relevant use statement, the definition of config, the config new function definition. So those things are getting moved. And let's do that now. And they said source.libs, a new file, call it lib.rs. And we're going to move a number of things. It's everything that's not in main, which for the most part, this main does need process because it needs, and it does need error, but it doesn't need file system. No, we need error. I'll just copy those things and move them back later. So all of this stuff needs to be here, right? And in terms of deletion, config is definitely leaving. Run is definitely leaving. Main just got a lot smaller. File system happens in the run function. Environment variables happens right here. Error happens, that's something that's returned by run. And then you have environment and process, which I believe stay. And then lib, they don't use environment, that's main function's job. And they don't use process because that's main function's job. And I guess I could put these in alphabetical order. A, B, C, D, E, F, G. Then we have config, which we have there. We have the new, which we have here. We have run, which is down here. We've made liberal use of the public keyword on config. Oh, yeah, things have changed. Go back to libs. So as you can see, a lot of things are now becoming public because we need to be able to call and use them. So your public function new, make it public. Side public goes before the function name. And run is now public. Everything just became public. We made liberal use of the pub keyword on config, on its fields and its new method, and on the run function. We now have a library crate that has a public API that we can test. Okay, so what they're saying here is we moved everything to the lib file and we put public on because now we can now publicly test our API. Publicly test our API meaning that we can create files that will use our public API as anybody else would and then test it to make sure the functionality works as expected. We now need to bring the code we moved to source.lib.rs into scope of the binary crate in source/main.rs as shown in listing 12-14. And things need to be changed in terms of name. So here we go. We should really take notice of the space here. So in a lot of languages, you have a spacing between the standard library and packages and things that you create. This would be standard library packages, and this would be a package we created, so there's space in between. You probably also do the same thing for third-party packages, but we'll find out later, I guess. Use mini-grep. Config. Mini-grep config. Oh, I forgot a public. The struct is public. My bad. Hub. And now that red line is gone. Cool. And then down here, let's move that out of the way. That stays the same. Oh, config was brought into scope. Actually, so it used to be fine. This error thing shouldn't be though. They just said mini-grep. Run config. And now we have that box error. So that actually worked. Which is slightly odd for me. I guess since it's direct, it was just able to call it. Okay. And config was explicitly imported. Let's make sure this runs though. Yeah, it does. We add a use mini-grep config line to bring the config type from the library crate into the binary crate scope, which we did here. Bam. And that's the reason why we can call it directly here. And we prefix the run function with our crate name, which we did here. Down here. The crate name, and the crate name has access to run. Public API. Now all the functionalities should be connected and should work. Run the program with cargo run and make sure everything works correctly. That was a lot of work, but we've set ourselves up for success in the future. Now it's much easier to handle errors, and we've made the code more modular. Almost all of our work will be done in source/lib.rs from here on out. Let's take advantage of this newfound modularity by doing something that would have been difficult with the old code, but is easy with the new code. We'll write some tests. Yeah, I'm gonna have to stop here because this is long. I hope that video was enjoyable. Hope it was good. Hope it was useful. If it was, feel free to subscribe. Outside of that, peace.